Okay, so now we're going to talk about assembly. Okay, so again, you will often hear kind of words, several words that are used interchangeably: assembly, board population, and soldering a board. So sometimes those can all mean the same. But the main thing is you're taking a printed circuit board, and then you're gonna put components on that board, okay? And you're gonna electrically and mechanically connect it to the board. And you're gonna connect all of those components electrically to the traces that we're gonna see on the board, okay? And so this slide presentation is specifically about your workstation setup and safety, and then a soldering tutorial. So yeah. So it's really important to, think about your workstation before you just start soldering. And for those, soldering is hazardous, okay, because we are using irons that are going to get very hot, okay, and it'll go to the next slides. But before we get started, I just want to say there may be some people who, for whatever reason, are doing this at home. And I would highly recommend that you go to a lab at your college to go do this work. And the reason I say that is because it's just really important to have a proper setup, and also to make sure that the people around you are aware of what a soldering iron is and how hot it can be. Okay, so I just make sure that those around you, and if you have a soldering iron on, that there's no chance for anybody else to get burned with it. Okay, so more important is that you have also a clean and organized workstation. Okay, and this is just going to help you stay organized, make sure you're not mixing up components, make sure that you're going to be safe. And you can see here, there's, safety glasses, which I highly recommend whenever you're first starting to learn how to solder. And this will just help you keep everything organized. In particular, once you start having a lot of components around, things can get mixed, and next thing you know, you don't know what capacitor that is, or a resistor, or whatever, and it can be confusing. So the items that you need, and hopefully you'll have at your setup, your station, safety glasses, important for you to wear, multimeter, that way you can troubleshoot what you've done. Very good lighting, so you can actually see what you're doing. The soldering iron, the needle nose pliers is really helpful, tweezers, a desolder gun if you have one, and then solder, electrostatic mat, and then wire cutters. Those are all just the basics of what you need. So yeah, so safety comes first, like it says here, safety in the lab is like wearing your seatbelt. You regret not wearing it milliseconds after it's too late. And that's very true when it comes to soldering. So being mindful of where you are and the hazards around you, the safety glasses, we've talked about that. And then this is where it starts to become hazardous, that the soldering irons can get in excess of 650 degrees. Okay, so that means that if it touches your hand, that it's going to burn right through your skin. And typically, if you get close, there's heat coming from this. So as you're getting closer to your hand, you immediately sense that, and you will pull your hand back, okay? Or you'll say, what am I doing? So just keep that in mind. And then also, you're working with electrical circuits. So, being mindful of what is touching what. And typically, where this can become dangerous is if you have tools or metal objects that you then put across your circuit that then cause it to arc. That can certainly cause a dangerous situation. It could even cause a fire. That's also why I like to keep my work area very clean. And sometimes, like when we're starting to solder components, you'll start cutting leads and there's a bunch of little metal pieces all around, and then you put your board on there, and the next thing you know, some of those little metal pieces have ended up on your circuit board, and then you go plug it in and you've got, some metal across something that shouldn't be. So that's why it's just important to, make sure you're really aware of your surroundings. So the ESD wrist straps can be very helpful, in particular when you're handling very expensive electronic devices, components. And I would also say it's really important if you're handling complex and especially expensive and irreplaceable components during the winter time, because I still get shocked every time, like I, get in it off in a chair, stand up, and, all of that is all the charge is sitting on your body. So make sure to grab that, in particular if you're using electronic components that are hard to get, expensive, because it'll damage them. There are a few IC chips out there that have protection, but for the most part they don't. So you should just expect that they don't. So let's see, the excessive heat from soldering. So, you want to get these components hot, or the leads hot and the board whenever you're doing that. But if you have the soldering iron too hot, or if you're soldering at temperatures that are not expected for that part, that can cause damage. So again, this is pretty critical for whenever you're handling sensitive electronics. So emphasizing again the situational awareness, be mindful of where you are. Also, your hair, it's really great to put it in a ponytail. Put it in a ponytail, get it out of your face, use your eye protection. Maybe you're already wearing glasses. And then there's lead in some of the solder, so wash your hands afterwards. And then we also, in our shop, we have like vents that we can use in order, like it kind of vacuums some of the fumes out. So if you have that in your lab, that's really nice as well. Okay, so whenever you start, now you've got the board, you've got your components, you've got your schematic, and you're gonna first take a look and inspect all the components before and after soldering. Okay, so the components should be as close to the board as possible without stressing the leads. And so as we're going through this, we'll show you how to properly bend the leads. And then, yeah, so just if you're like having to install it and then pull it out and then reinstall it, and you've for some reason bent some leads, then, if you're just doing a little prototype or whatever, then it's probably okay. But this is definitely something, once you get closer to your flight electronics, that you want to really be careful with it. And if you're starting to really stress these parts out, then you're just learning how to do it. It doesn't quite look right. Just get a new part. It's fine. A lot of these things that we're using are fairly inexpensive. So always, actually, when I order parts, I always order spares. That way, because I know I'm going to mess up or I'm going to lose stuff or whatever, then I can at least have those spares available. So also, you want to orient the components so that they have their value markings and they can easily be read after installation. If you can have the resistor color bands reading all the same direction, then that's great. I always forget to do that. So it's fine. It's just really easier for people to look at. And then when what we call the integrated circuit chips are to be soldered directly to the circuit boards, a socket is not used, then their pins are often slightly too far apart, must be gently aligned. So I typically like to use a socket for the IC chips, and you'll be installing one of those today in the activity. So for the soldering tips, it's easier to add solder or remelt it versus removing it. It's easier, and this is all just tips, so we're going over it. We're going to go over it in more detail, but this is all here for you to review later on if you wanted to. So it's easier to solder using the side of the iron rather than just the tip. Make sure that the iron is heating up, both the pad and the pin. Have good lighting, and normally I start with all of like the resistors and capacitors first, all the small components, and then you work your way up to like the integrated circuits or anything that's going to be tall, like connectors that are going to make it more difficult for you to solder. Okay, so I talked about this earlier, but about this term polarized, and that means that they have a negative and a positive lead. So we're talking about diodes, we're talking about capacitors. So make sure the polarized component is oriented correctly with the board. And again, usually what will happen is something won't work, like in the case of a diode, because the current just won't flow through that device. But in the capacitors, this can cause problems for sure, that could damage the part. So it's really important on capacitors. So some of the components have designated pin numbers. And so you have to, it's really, really critical to match up pin 1 on the component to pin 1 on the printed circuit board. And there's a few ways to do this. Again, we're going to go over these details further on with the activity, but I'm going to show you here. So there's a few different ways. You can see this is an IC chip here. There's 4 pins on this side, 4 pins on that side. Okay, so let me tell you what the pin out is. This is pin 1, 2, 3, 4, 5, 6, 7, 8. That is just how IC integrated circuit chips are designated. But if you're looking at a connector or something else, it may not be. So this is just for the what we call the IC chips. Okay. So in here, the reason I knew that was pin 1 is, first off, it's kind of hard to see, but there's circles here on these pins, and this is actually a square on the metal part by the hole. So that's one way you can tell it's pin 1. Another way is there's like this little notch right here. So usually when you see that notch, that sometimes you'll see a notch also on the IC chip. And so that can indicate. So, but check the part. And so if you're still not sure and you look at the part, because sometimes I do this, I like have the IC chip in my hand. I'm like, this is confusing. I still don't understand where the pin 1 is. I go look at the data sheet online and I find the data sheet for it. I look it up, and on that, it should have like some kind of drawing that will help you determine what the orientation of the writing is. But the point is if you don't put the pin 1 correct and you put an IC chip in, it will do something very bad, okay? And it would potentially damage the chip. This is also a situation where you could have a short between ground and power. So they don't really make any of these things interchangeable, like any direction. So you definitely have to be really aware of this. And you're gonna keep hearing this over and over again. So I just hope it sticks with you by the end of all of this. So this is just how you bend the leads for the resistors. You can use this if you have this around. Sometimes I just use pliers. If you want to do something really quick, you just use your hands. But the pliers also make a pretty nice bend. So it's a little bit of an aesthetic thing, but there are certain hole sizes on the board that will be for the resistors or capacitors or whatever. So you just have to get that right, or else it won't sit flat. Okay, so the through hole components. Again, this is what I'm talking about when I talk about through hole, and it literally just means that it's going through a hole, the lead. It's going through the board to the other side of the board. That's all it is. Whereas surface mount, the pad is on the one side of the board. You do not get any part of that component on the back side. Okay, so we'll again go through this, but you're going to insert the component leads through the holes on the circuit board, and then the body of it, you want this to be like flush. You don't want it to be sitting crazy or anything like that. Just make it flush. And then on the back side, you take these leads and then you kind of bend them a little bit at the angle. And that by bending it, it's going to not allow you, whenever, because you have to flip the board over to actually, you're going to solder the back side of this. So it just helps to keep it aligned and flat. Otherwise, it'll just fall through every time you do it. Okay. So you kind of bend it like this. And then with the tip, you're going to turn the soldering iron on. Okay. And then there's, I'll also say it's not on the slide, but there's a sponge that typically comes with it. And it's literally like the sponge you use in the sink to dry, wash your dishes or something, right? You want to put water completely on the sponge. It should be completely wet. Don't use the sponge without the water, or else you'll just burn the sponge. Okay, so get it wet, and then that is going to help you to clean up the tip. Okay, and whenever you pick up tips, a lot of times, or you pick up the iron, you take a look at it. Does it have a bunch of crap on it? Crud, black stuff, whatever. You need to clean it before you start soldering, or else it kind of, has contaminants in your solder. The soldering connection, which isn't ideal. So I like to clean my solder tip like all the time. So I solder a few holes and then I go clean it. And so I'm just constantly doing that. And ideally the tip should look shiny. So they're telling you here that you can also, after you clean it, then you can take a little bit of the solder and like feed it into the tip of the iron. And then that's going to allow it to kind of what's called tinning your tip. Okay, so it's just gonna put a little bit of solder on there that helps you. So then you take the iron and you put it at the hole where the lead is. Okay, so we want to touch, you want to touch the iron tip to not only the hole that's on the board, the little metal donut hole, but then you also want to touch the lead coming out. Okay, so you want to touch all three of those things because you need all of them to get hot. And then you just feed in solder with your other hand. So this means that you have to use your right hand or whatever your dominant hand is to hold the soldering iron, and then the left hand is going to be the one that's feeding the solder. So depending on where you hold the solder, it depends on how close your fingers are going to get to the iron. And we already talked about how bad it is if your hand and the soldering iron touches. So be cognizant of where your hand and the soldering iron is, as well as just in general where the iron is in your hand, because if you just are kind of waving it around, maybe you start talking to somebody, next thing you know, you touch something, a part of your body that you didn't want to. Okay, so yeah. Okay, and then in the end, you kind of want this like Hershey kiss of solder, it says when you're done. It should look like this, okay, and like this. And if you want some really good examples, if you have some like electronic boards that were done commercially, you can go flip them upside down, and there's going to be really good examples of what it should look like. But I think there's some more examples in our slide as we're going on. Yeah, so this is a good example here. And these should really be like shiny looking, and it shouldn't be, it should kind of be formed like this, okay? And you're about to see some examples of bad soldering, but the general thing is you don't want any cracks, gaps, or graininess, okay? So these are kind of examples of good soldering. Okay, so this is really important slide because maybe this is one of the most important slides for quality, because this is examples of bad soldering. So a lot of times, and you're going to find out as you learn to do this, that your boards aren't going to work. And a lot of times it's going to be because you were just learning how to solder for the first time and you didn't quite get the hang of it. Soldering is really an art form. It takes a long time to get really good at it, and it takes a lot of practice. So you're going to find it difficult initially, and that's okay. It just takes a while to get used to it. So just be aware. But the important thing is to understand when something doesn't look right. Okay, so you saw those nice pictures here, right? That's what it should look like. And then this kind of, there's different reasons why these are bad. Okay, so too much solder. I would say, well, too much solder isn't bad if the electrical connection is actually there. But this can also be a cold solder joint is usually what I see. And that means that you got like the pad hot, but you didn't get the lead hot because you didn't make contact with both of those things with the soldering iron. So this one is very bad because electrically you're not going to be connected and it won't work. You'll look at it, you'll say, oh, it's soldered. It's not actually making an electrical connection with the lead. It's weird when this kind of stuff happens. But usually this happens because you did not apply enough heat to that area. Okay, then you could just like not have enough solder at all, and that would just mean you're again potentially not electrically connected. Certainly, like if you got like a power, something with power, and maybe this isn't enough to carry certain amounts of current. So you kind of get this in between of not too much and just more than enough. Too much heat, you can start seeing some kind of browning or graying of the area. Usually, a lot of times you can clean this up, but if you continue to put too much heat, then you can certainly start tearing up the board. And then this is also one of these really bad ones, is whenever these two pins were supposed to be soldered, but not actually touching. And so you can see here that we've now created an electrical connection between these two pins, and now we have a short. And it turns out that this pin is ground and this pin is power, or whatever the situation is. This is ground and this is your signal or your output. Whenever you do this and you turn your board on, and this is why it's so important to inspect it after you finish soldering it, that you would potentially burn up the chip or do damage on the board. So bad situation there, okay? Also, the too much solder, whenever you have this can tend to happen. So you put too much solder on and then it starts bleeding over into the next pin. So again, it's going to take a while. So tonight is a great, or whenever you start working on this activity, it's really good to just do everything you can so you get a lot of practice in. Okay, so after the inspection, if the solder is good, use a pair of wires to cut off the excess lead length, so close to the board. And I would say not necessarily as possible. You do want a little bit sticking out. And the important thing is it's weird, like some of the leads, whenever you cut them, they will just fly off at high speeds, potentially to your face. So I often will turn the board away. And that's why it's really good to wear safety glasses, because this is one of the reasons. And then, but oftentimes I just have gotten used to where I turn the board away from my face and then cut the leads. So, but the cutters are sharp. So you want to make sure you're like aware of where the cutters are going into and it's not going into the board. Okay. So this is the surface mount soldering, and this is sort of what it looks like. I think we will probably wait for a lot of this until the second semester, because I've already given you a lot of information. I don't want you to get started on the activity. Very similar, though, I'll just kind of briefly go through. It's very similar to the through hole, except that you have to use tweezers and it becomes a lot. You can see things are now starting to be very tiny and small. And so you have to be aware of where all these components are, because you'll just drop them all over the floor easily. So good reason to order spares whenever you're doing surface mount. So again, we'll be going through this in more details next semester. I'll keep moving around here to the end of it. Okay, so you've soldered things, and you know, you have some problems with it right now. You see that you've shorted some pins. You've got too much solder going on. You don't know what to do. You know, you can some things are easily removed. Okay, so solder can be removed. The components, depending on what they are, there's various levels of difficulty with it. So like a resistor, capacitor, those kind of things can be removed fairly easily. Whenever you have soldered in an entire IC chip and didn't go through the process of checking it all along the way, and now you've got like 14 pins soldered in, that becomes a very difficult thing to unsolder without using advanced desoldering tools, which you probably do not have in your lab. So there is something called a solder sucker that will remove the solder, and I think that in the activity I have a video part showing how to use this. This is basically like a pump though, and at the end of it here, you'll put this over the board. First you'll heat up the hole or whatever it is you want to unsolder, and then you kind of put this directly on top of it while the gun is there, and then hit this button and it just creates a big vacuum, and it'll actually just suck up the solder. But the solder has to be liquid, so it has to be hot whenever you are doing this. And this is just how you do it. Again, you prime the solder sucker with the pump, and then you place the soldering on the solder that you wish to be removed. And then once you've heated the solder up, you see it starts to flow, what we call flow, and then you're going to press the release button and it'll remove the solder. Okay. This is also something else called solder wick. So it is like a copper braid, and you can also use this to it basically will just absorb the liquid solder. This wick is a little bit dangerous for the board itself, and that's because a lot of times people use it and then they remove the soldering iron before you remove the wick, and the wick will actually cool instantly, and then you go to remove the wick and now it's soldered to your board, and you just will rip off some of the traces on the board. So be very careful with that wick, and I would try to use the desoldering pump if you have one, and then move to this. But in the video, I definitely have a demonstration of how to do this. So if in doubt, it's usually wiser to sacrifice the component by cutting its leads off and removing the leads one at a time. Okay, so this will avoid damaging the traces on the board. So just start cutting the component off if you think you can do it without damaging the board. Okay, so that is the end of the lecture. So I'm gonna